Hello everyone. Today let's solve the problem heap operations, right? So this was asked in Codeforces round 357 division 2, right? So you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem, right? So the first thing here, what the question states here. So we are given a log of heap operations. So here we have been given a log of heap operations. Just give me a second here. Yeah, we have been given a log of heap operations. One is insert, this one you can clearly see here, right? Insert x, this one is insert x, another one is getmin x, and another one is remove min. These three things, right? So we have been given a log of heap operations: insert x, getmin x, remove min. But some operations might be missing due to the torn pages. So here we have been given these three operations, and some of the operations might be missing due to the torn pages, right? So what is our main task then? Our main task is to add the minimum number of operations such that all operations become valid on a minimum heap, right? So our main task is to add the minimum number of operations. So we have to add minimum number of operations, minimum number of operations. Just keep this in mind. We have to add the minimum number of operations such that all operations become valid on minimum heap. So after adding this one, minimum number of operations, all the operations has to be valid on minimum heap. All the operations has to become valid on minimum heap, right? So that's our main task. Our goal is to add the minimum number of operations such that all operations become valid on the minimum heap. So we must preserve all the original operations in the given order. So we have to preserve all the original operations in the given order. So this is very important, right? So our output should be the corrected full sequence of operations using the priority queue or the minimum heap. So just keep this in mind. This is very important. Our output should be the corrected full sequence of operations. It should be full sequence of operations, means corrected full sequence of operations using priority queue, using priority queue, or you can just call this one as min heap or min priority queue will be going with, right? So uh, we'll be making use of the priority queue, right? So you would have already guessed that the approach that we'll be going with will be priority queue, right? So this is the question. I'll just read out the question loud again. So just listen to this. We are given a log of heap operations, these three: insert, get min, x, and this one, remove min. But some operations might be missing due to the torn pages. Our task is to add the minimum number of operations such that all operations become valid on the minimum heap, right? So I hope this part is completely clear, right? Then we must preserve all the original operations in the given order. Our output should be corrected. Our output should be the corrected full sequence of operations using the priority queue. Nothing but the minimum heap or minimum priority queue, right? So this has to be min priority queue or this one, min heap, also known as min heap. This is fine, right? So we can perform. We have to perform minimum priority queue or the min heap operation. So this is it for the question. This is it for the question. For the input, let me come here. We have been given four inputs here: insert 3, insert get min 4, insert 3 and get min 4. We have been given insert 3 and get min 4. So the output will be 4 basically. Output consists of the 4. This thing, what do you call, insert 3, remove min, insert 4, as well as the get min 4, right? So here we have been given, in after inserting 3 we haven't been given insert 4. To get the get min 4 we have to have the insert 4, right? So first, after inserting the this one, we don't have to, uh, there is no operation getmin 3, so we don't want this one, insert 3, so we can just remove min after insert 3, then insert 4 and get, we can get the minimum 4. This we can do, right? So this is correct output in this case. Same goes with the second output as well. For here we have four inputs: insert 1, again insert 1, remove min, get min 2, right? So we have to go with the output 6. So insert 1, again insert 1 accordingly with the input. So we will remove min, we will remove this one, we don't need this one, right? Then to get the minimum of 2 we have to insert 2. So that's what we are doing here, insert of 2, and then we are getting the minimum, I mean the value 2, by making use of get min 2. right? So I hope this part is completely clear. This is very easy to understand. They have given us wonderful examples just for the sake of understanding, right? I hope the input output part is completely clear along with the question. Now let's do one thing. Let's discuss the approach followed by the this one complexities, and then let's write the code. Initially, let's discuss the approach first. So we were given two examples in the question, right? So I'll be considering the first example for the approach. So here we have two, insert of 3, insert of 4. The output we have already seen this one, right? So the output that we need to get here is this one for insert 3. This one we have to remove this one 3. Then we have to insert 4. Then we have to go with the getmin of 4, right? So if you are not able to see this one, this is nothing but the getmin of 4, right? So I hope this is clear, right? So this part is completely clear. Next, let's move on with a step-by-step this one explanation. Before moving on with the step-by-step explanation, I just want to tell you that we will be making use of the priority queue or the minimum heap, min priority queue or the minimum heap. Just keep this in mind. The data structure that we'll be making use of would be minimum priority queue or the min heap, right? So let's move on with the step-by-step explanation here. So we have this one. We have considered the same input, right? So let's go let me explain accordingly, right? So here first we will insert 3. First we have to insert 3. Here we have been given insert 3, right? So first what we'll do, we'll insert 3. Now heap consists of 3. Heap consists of 3. We have inserted 3. We have inserted the element 3. So heap consists of the element 3. So now we have the operation getmin of 4. Heap stop is nothing but 3. Heap stop is 3. Now suppose consider this one as heap. We have 3 at the top. We have only one element, right? So we have only one element. So we have 3. Heap stop is 3, which is less than 4. Which is less than 4. Basically, we have been asked to get the value 4 by making use of getmin, right? Getmin of 4. So here in this case, we have this one. What do we call? The value 3 at the top, which is less than 4, which is quite obviously less than 4. So we must remove min. First we have to remove this element. And then insert the element 4, and then we have to get the value 4, right? So heap stop this one equals 3, which is less than 4. So we must remove min of this one, remove 3. So what we'll do after this step, first we will insert 3, then we will this one, what do we call, remove 3. Then we will remove 3, right? Or we can just give here remove min, right? So now heap is empty. After removing at the top we were having 3, we removed this one, right? Remove min, we performed remove min operation here. So we removed 3. Now heap is empty, so we must insert 4, because to get the value 4 by making use of the getmin 4, so we have to first insert 4. So now we will insert the value 4. Insert the value 4. So now we have successfully inserted the value 4, right? So now we will finally do getmin of 4. So now we will do getmin of 4 to get the value 4. So now the output would be insert 3, then we removed this one, remove min, insert 4, because we have the minimum value we have to get is 4 by making use of the getmin, this one, right? So finally insert 4 and getmin 4. So the output that we got here is insert 3, remove min, insert 4, getmin 4, right? So we'll be making use of priority queue data structure for this. We have made use of, right? So the same thing we have to articulate in the form of code, right? So the same thing we have to articulate in the form of code. So let me come here. The output that we got here is insert 3, remove min, insert 4, and getmin of 4, which is equivalent to the output that they have mentioned for the example 1 in the question. So our approach works absolutely correct, right? Our approach works absolutely correct in this case. Now let's do one thing. As we are completely familiar with the approach, let's discuss the complexities. Right? So here in this case, what would be the time complexity and the space complexity? The time complexity would be big O of n log n. So the time complexity would be big O of n log n, because uh, each operation, each heap operation, right? So we are making use of here insert this one, remove min. these two heap operations, right? So we'll be going with the priority queue, basically min heap or the min priority queue here. So we will be going with the insert or remove min, which basically takes logarithmic n, and we may perform up to n such operations. We may have to perform n such operations. So overall time complexity would be big of n log n, right? So each heap operation takes this one big of logarithmic n, and we may perform up to n such operations. So overall time complexity would be big of n log n, right? So overall time complexity would be big of n logarithmic n. So what would be the space complexity here? The space complexity would be big of n. The space complexity would be big O of n, right? So why it is big O of n? Because we might store the heap and result list of the operations, right? So we might store the entire heap and result list of the operations, right? So overall space complexity would be big of n here. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n log n and the big O of n, right? I hope the complexities part is completely clear along with the approach. Right now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code. So here, first thing is we will be making use of the this one fast input and the fast output. So let me import the input output package. So I'll just go with java dot input output dot start. And also let's make use of the util. We will be needing the utilities, right? Sorry. We'll be making use of the utilities, right? So let's go with import java dot util dot start. This is fine. Uh, let's go with the class here. I'll just give main here. This is fine. You can just give any class name within the main class. So let's go with the custom class to represent the operation in the log, right? So each operation in the heap or the priority queue will be making use of the priority queue, right? So each operation in the heap will take us big O of logarithmic n, right? So we have to write the custom class to represent an operation in the log. So let's write that one very quickly. So this will be static class operation. So this is fine, operation. So within this class what we'll be doing, let's go with the operation type. Three operations we have. One is insert, one is getmin. By this we know via input itself. Also we have remove min as well. So we have to remove if the element is smaller or smaller, basically. In the question they have given that it will be initially smaller. We have to remove that one, and then we have to add, then we have to insert and get the value that is in the getmin, right? So we have three operation types, nothing but insert, getmin, remove min, right? So I'll just go with the string type. Type is of the type string, this one string. And let me go with the int value as well. This value represents means here the value is associated with the insert and getmin, right? So getmin we are having the value, and we have to insert the value as well. Remove min we can just give directly remove min, right? Remove min. So value is associated with the insert and getmin. We know this one via approach or through the approach, right? So let's go with the operation next. So I'll just go with operation here. So parameters, I'll just go with type here and value. So this will be type and value will be of the type int, basically. So this is fine. String type, and this is fine, initialization part, right? So this will be type equals type, and also this dot value equals value. So this is fine. Let me come out of this one entirely, and now let's consider this one at override. So I'll just go with the annotation override here. O has to be capital, right? So this is fine. So let me go with public. So this one string. So we have to convert this one to string. So I'll just make use of toString. So this is fine. What we are doing here, what we will be doing here, we will be making use of the this one remove min, which has no value, so we will only print the type. In this case. Let's make use of simple if condition for this, right? So if this one type dot uh, let me give here equals of this one will be remove mun. This one will be remove mun. So this one will be return type. Return type. So for insert and or the getman, for the insert or the getman, we have to print type followed by the value. We have to print type followed by the value. Right? For the insert and getman I'm speaking of, or getman, sorry. For the insert or getman, we have to print the type followed by the value. So I'll just go with here return type is this one. Let's concatenate this one or append this one along with the value. This is fine. So let me come out of this one entirely. We are done with this part, right? So next let's go with the main function. So here let me give this one. So and let me do one thing. Let me delete this one. No, we don't need this one. Also let's make use of the throws and this one input output exception here, or else we'll get the error here. So I'll just go with exception. This is fine. So within the main class, what we'll be doing here, with the main function. So what we'll be doing here, let's go with the fast input reader and the fast output reader. For the fast input reader, we'll be making use of buffered reader, buffered reader. So this will be new buffered reader of new input stream reader. This one would be system dot in. This is fine. So here this one will be print writer. This one pw equals. So this one will be new print writer. I have just made use of the variable pw here. So I'll just make use of new. Here it will be buffered. Instead of the buffered reader, let me make this one buffered writer. So this is fine. Buffered writer of what? So this one will be new output stream writer. So here let me type instead output. So this one has to be output stream writer, output stream writer of let me give system dot out, system dot out. So this is fine. This is fine. So let me come out of this one, or let's move on with the further things, man. So here we should not be going anywhere. So this is fine. So we have to read the total operations given in the log. So we have to read the total operations that is given in the log. So let me assign n to integer, which is basically in the integer, right? So I'll just go with the integer dot parse int of this one will be buffered reader dot read line. So this one will be read line. So this is fine. So the next part here would be, so we will be making use of minimum priority queue, or let's do one thing. Let's simulate the minimum. Let's make use of the minimum heap to simulate the operations, right? Or we'll be going with the minimum priority queue. So I'll just go with here priority queue, priority queue of this one integer. So this one pq equals new, this will be priority queue. We have solved n number of problems that involves priority queue in the JavaScript or the node already, right? So we have solved around already 50 problems, I think. So basically there within those problems, there were many problems consisted of the priority queue. Means we solved those problems using the priority queue data structure, right? So we should be having the idea. Programming language is different, but we are solving different problems apart from those problems, but the concept is same, priority queue, right? So we have already solved n number of lead code problems, n number of Codeforces problems, uh, right, using the priority queue. So now we'll be making use of the min heap or the min priority queue for this particular problem, right? So here we are making use of the min heap to simulate the operations. After doing this, so finally we have to go with the final corrected operations list. Means let me go with the list here. So this will be operation list of operation. Let me go with the result equals new. This one will be array list, new array list. So this is fine. This is fine. Let's go with a simple for loop now. Let's go with a simple for loop. So let's move on with the iteration part here. This will be int I equals 0, I less than n, and I plus plus. So this is fine. Within the for loop, what shall we do? Let's read one operation. Let's read one operation. This will be string line equals buffered reader dot read line. Buffered reader dot read line. We are just reading one operation at a time. Then we have to split the operation into parts. For that one, let me go with here string. So this one, let me consider the variable name parts equals. So we are going with the split, right? So let me go with the split here and leave the space here. This is fine. So after this step, let's move on with the this one. First thing is we have to insert, right? So we have to insert the values to the minimum heap. So accordingly, with the approach that we discussed, first step was to insert the value to the minimum heap or the min priority queue, right? So to the priority queue basically. So here this would be if parts of 0 dot equals first one is insert. If we have insert, then what we will do, let's assign the value x2. So integer, so this has to be integer, right? So this will be percent of this one, parts 1, parts 1, parts of 1, first index. So this is fine. We are just extracting the value to insert. We are just extracting the value to insert. We have the here value along with the insert here in the first line. This one I'm speaking of, man. See here, we have been given two inputs. One is insert 3 and get min 4. Here we have the value 3. That's what here we have written. If parts of 0 dot equals insert, if insert this one character, this one is present, naming insert, then that part of one means next value. After the string, we have the numerical value. This one we are considering this one, right? So this one we have to consider parts of 1. So that one we are making sure that it is converted to the integer by making use of the percent here, right? So this is fine, easy to understand, right? So we have to extract the value to insert. So let's insert into the minimum heap. We have successfully extracted now the value to insert. Now we have to insert into the minimum heap. Nothing but we have considered priority queue here, this one variable pq. So this one will be pq. I'll just make use of the add operation of x. This is fine. Of x. This is fine. After inserting into the minimum heap, we have to add this one to the result list. Means I'll just go with the result dot add of new operation. New operation of this one. Within the string, let's give the insert, and the value is nothing but x. The same thing we have to display in the form of output, right? So here this will be x, right? So I hope this part is completely clear, man, right? I hope this part is completely clear. So next, let's do one thing. Let me leave a single line here, or hmm, let's go with the so else if here, else if. So this one will be paths of 0, this paths of 0 here, this one dot equals of getman. So if it is not equivalent to getman, if it is equivalent to insert, then we have to insert that one to the priority queue. If the insert value, I mean, if parts of 0, if the first one itself is here, see here, first itself we have the getmin of 4 and insert of 4. So this value itself is same, then we can directly this one get the value of the 4, right? So because we have already inserted 4, suppose just for the example sake here, consider this one. We have the input here, insert 4. First one, this one is number of inputs, right? So I'll consider 1. So this one will be insert 4. Now we have getmin of 4, getmin of 4, right? So we have already inserted this one 4 to the priority queue. We just have to get the value for that set by making use of the getmin, right? So for that one, we have to write the condition. Same thing we have to articulate in the form of code now. So here in this case, else if parts of 0 equals to getmin, then what we need to do, we can directly make use of this one. So here this one, right? So here this one. What did I do? Oh, we have to select this one entire thing, right? Just give me a second here. Yeah, let me copy paste this one and make the necessary changes. This one will be int x equals integer not percent of parts one. This remains same man actually, right? So it is directly equivalent to the getman. The value is directly equivalent to the getman. Insert value is directly equivalent to the getman. So here we are just uh, considering this one, the right part, nothing but here this one value. We just have to consider the value, right? The right part. So that one we have written this one successfully. This is fine. Next, after this part, so let's do one thing. What we have to do now, we have to remove all the elements that is less than x to make the x the new minimum. We have to remove all the elements that is less than x to make the x the minimum, right? So let's write the while condition. So priority queue should not be empty. Then only we have to move forward, right? So for that one, while priority queue is, so let's make use of the is empty operation that is provided by the priority queue. And also this one, priority queue means the value has to be less than x. If the value has to be less than x, then we have to go with the removeman. Then we have to go with the removeman, and then we have to remove that value. This one I'm speaking of. So here the first example itself, the same example, right? We considered here first we have insert 3 and getmin of 4. So this value is not equal to this one, right? So here this is 3 is less than 4. 3 is less than 4 when means priority queue is empty and pq dot peak is less than x, right? So this one peak, we can consider this one peak less than x. Then what we have to do, we have to remove the invalid minimum values. Means we have to go with, first we have to remove this one, then we have to insert 4, and then we have to get the value from the getmin 4. So that's what we did in this one as well, approach, right? So the same example that we considered. So let's articulate the same thing in the form of code. So here in this case, pq dot peak. So this one, if it is less than x, if it is less than x, then what we will do? So let's remove the invalid minimum values, nothing but pq dot poll here, pq dot poll. We are just removing the invalid minimum values. After that, we have to add the missing removal. Means I can just write in this way, result dot add of this one new, this will be operation. So this will be, as per the output, we have to go with the string removeman. This one would be -1. This one would be -1. We'll remove that value. We are removing the value, or we are adding the missing removeman. We are done with this part. We are done with this part. Next step, what we will do, if the heap is empty or top is greater than x, if the heap is empty or top is greater than x, we must insert x to satisfy the getman x again. So we went with the lesser value. This time, previously we went with the lesser value, right? So here in case if it is greater, means insert of 5 we had, means so first what we need to do, we have to compare this one, we have to remove again the greater value. Suppose we had 5 in place of 3. Suppose we had 5 in place of 3, then we have to same thing do, this one removeman. We have to make use of removeman. We have to remove the value 5, then we have to insert 4, and then we have to go with the getman of 4. Then we have to go with the getman of 4 to get the value of 4, right? So this one we have to articulate in the form of code. Let's do the same thing now. So I'll just come here. So here, if it is greater than x, then we have to insert x to satisfy the getman of x, right? So let's write the simple if condition here, pq dot, if it is empty, so this one is empty operation, or pq dot peak here, pq dot peak, if it is greater than x, if it is greater than x, then what we have to do, we have to go with pq dot add of x, pq dot add of x. This one we are just inserting x, so it's now the new min, it is now the new minimum. So this one will be result dot add of, this one will be new operation of, so here it would be insert comma x, insert comma x. This is fine, insert comma x. We are just recording this insert. So here, what we are doing, in the previous line pq dot add, whatever we have written, we are inserting the x, right? So it is now the new minimum, it is now the new minimum. Means Here if it is greater, then we will be making use of the remove min, and then we'll remove that one, and we have to insert the get min value, right? So we have to insert the get min value, then we have to go with the inserted value, right? So we have to record this insert basically, right? So this is fine. We are done with this part. Next, let's move on with the next operation. So we have to add the get min operation. We have to add the get min operation. So I'll just go with result dot add of new. This one will be operation of this one will be get min comma x. This is fine. So here in this case, let's write one more else if condition here. So here if the parts of 0 equal to remove min. So here in this case, if the parts of 0 means the first index value, the value that we are considering, if it is equal to the remove min, then we need to do certain things, right? So let's write the condition for that. So here I can just go with parts of 0 dot equals. So here this would be remove min within the strings. So what we'll do, let's make use of the simple if condition here. Let's make use of the simple if condition. This would be pq dot is empty. Pq dot is empty. This is fine. If it is empty, if the heap is empty, then we have to insert the dummy value before the removement, right? So we have to insert the dummy value before removement accordingly with the approach, right? So for that one, we are writing the simple condition here by making use of simple if condition. We are just articulating the same thing whatever we discussed in the approach in the form of code. So within this if condition, let's insert the dummy value to avoid removing from the empty heap. This would be pq dot add of 0 and after inserting the dummy value, we have to record the dummy insert, right? So this will be a result dot add of new. This one will be operation. This one we have made use of the insert, right? So this will be insert comma 0. So we are inserting the dummy value at the 0, right? Dummy value 0 basically to record. Now we are recording the dummy insert here on this step in the line number 54. So we are done with this. Next step is to we have to remove the minimum value. We have to remove the minimum value, right? So we have to remove the minimum value. For that one, let's make use of the poll. Let's make use of the poll operation, right? So this is fine. Let's remove the minimum value by making use of the poll here. We are successful. Now after removing the minimum value, we have to record the minimum this one removement. We have to record the removement. So this will be result dot add of new. This will be operation of this one will be removement comma minus 1. So this is fine. So this one would be here. We have come to the end of the code. Now we are left with only one thing. So we have to print the total number of operations in the corrected log, right? So we have to print the total number of operations in the corrected log. Means this is the input output part, right? So I'll just go with pw dot. So let me give here println. So this will be result dot. Uh, let's go with the size. So in simple terms, what we can say, we are just printing the total number of operations here in the corrected log. So let's go with a simple for loop in the next line. So this will be operations. So operation, right? So this will be, let's consider OP, this one, a result. So this will be, we have to print each operation in order. We have to print the each operation, all the operations, right? So here in the order, you can clearly see in the output, we have got insert 3, total number of operations here 4 that we need to display. Then insert 3, all the operations in the order. Insert 3, remove min, insert 4, and then get min. All the things we have to display, right? So here, let's print each operation in order, nothing but pw dot. So here in this case, I'll be making use of the println of each operation is nothing but op from the operation, right? Op we have considered in the for loop. So this is fine. We are done, almost done. After doing this, we have to flush the output. Means here this would be print writer. This provides the flush. We are flushing the output. We have to just flush the output. We are done with the code. So this is it for the code, right? So I hope the coding part is completely clear. Now before this one, what do we call, before submitting this one, or before checking the code with the different inputs, let me copy paste the signature starter template. So here, let me come here. So let me paste this one over here. So you can clearly see here, you can clearly see your signature starter template. So you can just ignore this one. So just concentrate on the logical part. So we are done with the code, right? Let me try with the different inputs for this code. So let me run this one. So we have, oh, this I has to be capital here. Line number 40. Where is line number 40? Yeah, let me make this one capital I. So let me run this one again. Oh, we have what we have. So this I has to be small now, not the capital. So line number 54. So yeah, is empty. This has to be small I. So let me hit the run button again. So yeah, now we have the output for insert 3, remove 1, insert 4, get 1 4. This works absolutely correct, right? So we have already discussed this one. This example itself we have considered for the approach as well. So let me consider this input, the output that we need to get here as 6, this one, right? So let me copy this one and paste it over here. So we have insert 1 here, we have insert 1, this is fine. Insert 1, again insert 1, this is fine. So 1 we have twice, so we have to remove the value 1 twice, right? So remove 1, this is fine. And we have the remove man, so this is fine. Remove man, they have just mentioned remove man. We have to get the minimum, nothing but the value 2. So first we have to insert to get man. So this works absolutely correct, right? So this is fine. So we have the 6 operations here. So the number of operations we have to mention, nothing but 6. We have got the correct output for this particular input, right? So the code works absolutely correct. Now let me copy this one, let me paste it over here. This is problem C. We have already selected C, right? So this is fine. Let me hit the submit button. I hope this works for all the test cases, man. This question is given purely to understand the basics of this one, priority queue or the heap. So here we are performing the, we are going with the heap operations itself, right? Or the priority queue operations, right? So this question is basically uh, given to understand the basics of this one, priority queue or the heap, right? So now we can clearly see here the code got accepted, means it works for the code, whatever the code that we have written works for all the test cases, right? So now I hope whatever the code that we have written is completely clear. I mean, I hope the solution part is completely clear along with the approach and complexities. For now, this is it. Thanks for watching, guys.